as a different strategy for full permission to write into a group, I guess we're considering that federated. And the other question I had around that is, would it make more sense to implement bots outside of the peer, or would it make more sense to include that as actual functionality within super peers?
This is such a good conversation because it becomes hyper complex. It takes everything that we've talked about with the various permutations that can happen, and now then when you introduce bots, it then introduces another variable that creates different combination of all those three things before. You can do bots decentralized, you can do bots federated, and you can do bots centralized. It's certainly easiest to do bots centralized. In fact, you can think of all centralization, all servers as just a bot. So before diving into that, I want to make sure, first of all, two things. LightNet, do you feel comfortable moving forward with the information you already have? Or would it be better that we like break out and start doing some code stuff of the things we've already discussed? Because we could save this bot conversation for a podcast versus wanting to make sure I'm not bottlenecking anybody in making advancements, especially with the examples you've been doing are great examples for the community to reuse and share because they're such great case studies on like, here's this feature set, here's this feature set. Or is it more useful to you that we continue this type of high level discussion? Yeah, these are insanely complex subjects, which is why the analogies. Sorry, I should say cryptography is a very complex subject, and that's why I try as much as possible to have the cartoon explainers and stuff, and then boil most of these concepts down to analogies like the layers. Um, and but then there's different ways you can combine these things, and then that's what's leading to the complexity. So for clarity, should we go forward and talk about this new analogy of bots? Which is still going to be high level and isn't or or do we need to stop and actually show code? Well, I guess Yachin already posted some code about how to mix things. Are you able to move forward with what you wanted to do, even at a code layer, actually implementing, or are you still confused or need help or more code?
Is there a shared code space we could use so where LightNet could push maybe an example that has his problem and we could look at it?
Do you have that glitch up?
Oh, so technically Gun doesn't keep the timeline around unless you keep saving it as a set every time you set the time again.
Do you want the history LightNet, or do you want just the latest state of okay. Um, Is it okay if we switch over to Jitsi so I can share code, and then we can also do the audio, or I can screen share?
Do it.
Invite us.
I'll send it in the chat. Give me 1 second. I probably only have like 10 minutes left.
I probably have less time than that, but I'll just drop out whenever I'm ready to go.
Okay, so this winds up doing a video, just as a heads up for anybody. You don't have to do video, but I need it for the screen sharing. So I'm gonna stop talking on Discord and switch over to Jitsi. Okay, can you guys see my screen? Okay. And do we have everybody?
Yep, ready to go. Mm.
And Lightnet, you're here too? Okay. So let me jump over to, I don't know if this is going to directly help, but let me jump over to, okay, so for a multi-user collaborative object, that's going to be trust, grant, okay. And then do you want the data to be private? Do you want it to be do you want it to be a multi-user writable private data or public? Okay, that is easier to start with. So I just want to run through a couple things. I'm going to run through this code really quickly because it's easy to get confused because there's 3 or 4 different layers. So the ideal API is, let's say, me.get blog post.get, let's say it's by date, which is 2019 9/18, dot put, and I have this data structure. Actually, var blog is equal to this, and then I blog.put title yay cakes body whatever, and then I do blog.grant trust Alice, and Alice, so var Alice is equal to gun.user Alice pub key, and me is obviously, whoops, maybe I'll increase there, me is equal to gun.user by itself. All right, so this is, to me, like the dream API that I want for dealing with stuff. Now, I should note that there's already a couple different layers here in terms of how we could interpret this. When I when I trust Alice with this blog, am I trusting Alice with a single property, with the whole node, but no layers underneath, or the whole node and all layers underneath it? So let's say that's category A, B, and C. So those are 3 variables that we have to consider on their own, okay? Which leads to usability of the API and also confusion, because there's 3 different ways to approach it. So what Grant is doing right now underneath is, trust, here and here, is it already kind of works for this, but it has a certain set of assumptions. It's assuming that it's on a per property basis, and it's then assuming a path-oriented structure, which is that there is some type of hierarchy to the data, and that immediately limits its use case. So you can see that I grab gun, which is this. I grab the user, which is me, and then I grab, and this is outdated, so this should be updated to user.is actually .c. So that's an update that already needs to happen. And then here's the path. And the path, in this case, in this example over here, which type of, to what extent is trust granted? And then what hierarchy? So in the path case, the path would be my pub, well, actually, sorry, it's not my pub key. It is blog post, pub key plus blog post dot 2019/9/18. So that's the path. And effectively, the pub key is going to be swapped out for each person. And we then look at this path. And now there's two pieces to it. Another two pieces, right? Another two pieces, X or Y. So we're dealing with a permutation of A, B, C across X or Y versus the hierarchy is UID or path. So if you take the combinatoric of 3 plus 2 plus 2, like you're dealing with like 16 possible different permutations of how this could be implemented. And then hopefully not confusing those things while you're implementing it. All right, so we have the path, we have me, the user. So what I do is I first need to have metadata that states who is allowed to write to this path, and that's a separate data structure, right? So that's this other data structure. It's the metadata. It's the access control list of the data itself, which is going to be saved either on that relative to that path or relative to that UID. So it's fair to be confused about what's going on. You can map all this stuff out, and there's logically a necessary way of the different options, but I haven't stabilized this API because I'm not sure which one is going to be the most useful for people or should be the lowest level one. So the first thing I do is I want to grab, on myself, I go to what I'm calling the trust table, and that's metadata. And then I want to go to the people that I'm giving trust to, which in this case is myself, if you have private data. But this step isn't necessary if you don't have private data. So then when you add in public data versus private data, there's an extra two factors, which then makes it even more complicated. So, so let me read through what's happening here. I have to get on track myself. I got like probably another 5 minutes. So first, go to my trust table and look up myself on my own trust table, and then traverse into the path that I'm just, this isn't even an incremental path. It's just storing the path as a full direct key. And give me the result of that. The result of that is going to be, an encrypted blob, because I don't want people to be able to modify my trust table. So I then decrypt that secret because I'm sharing a secret with myself. I can use my own public. I can use my own cryptographic key. So I wind up using my own cryptographic key to decrypt this trust table. If nothing exists there, if there is no secret, I have to remember to create one. And so that's what this line is saying as well. If there's no secret, then let's randomly create a cryptographic key. I then want to encrypt that secret key with my key pair, and then I want to save it back to that path. Okay, and this secret here is the shared secret that I can give to other people if we're dealing with a private case. You said that we could deal with the public case. Sorry, I thought Grant only dealt with public data, but I guess not. Now we need to do the next step, which is to actually grant the other user read permission. So sorry that I've now switched to the private case. And that confuses when you switch things mid-case because they all have their own separate implementations. So what I then do is, this is who I'm granting I'm granting access to somebody, and that's Alice that we passed in right here, which happened to be correspond to this command here. So I know that there's a certain schema that C has for every account, and I know that I can get her public key from the root level of her account. However, dealing with private data, I have to make sure I'm using her EPUB, which is her encrypt public key. I want to reference everything that I'm doing by her public key, but I want to only encrypt with EPUB. So now that I have both her public key and her encryption key, the ability for me to encrypt to her public key, I then perform the key share experiment, which is I mix my keys with her encryption key, and that gives me the common encryption key, which is separate from the decryption key, which is separate from the path to the data, which is separate from the data on that path. Does that make sense? So there's a lot of different layers. Now, finally, I'm then going to send Alice, this other user, the secret to decrypt that data by encrypting it with the common key between us, as Yachin explained earlier, and this is the code for it. And I then encrypt the secret with the common secret into an encrypted blob that I then save to the trust table on on Alice's regular public key, versus at the beginning I was looking at my public key, on the same path that corresponds to my path, but on her account, and I then save the data. So now I'm granting Alice access to this private data. The sweet thing is, this, once she's able to read, oh right, I'm supposed to go to trust, not grant. Grant is about read. Ah! Oh, trust is not even
Yeah, trust doesn't work yet, so grant was probably the better example to go through anyways.
Oh, right. Interesting. Okay. So the cool thing is these two things can work together. The goal is that trust should be able to work whether the data is private or not, which creates multi-user collaboration. And grant is only for read permission, but you can get multi-user read and write. Sorry, you can get multi-user write on private data by just combining with trust. Okay, so now at this point, you're going to be doing the two operations, which is, first, you want to grant that Alice can read this blog post, and whether it's public or not, maybe that doesn't matter, so you skip that. And then you do blog.trust Alice. And we can then layer that with grant, where it's going to be very similar, but the naming here is confusing. This should be grant versus trust, right? So trust is going to do two things. It's going to do what Yachin explained earlier. And the way it does it is you create, like I did over here, you create a separate table where what you save that table is going to be probably like this: user.get. Sorry, let me switch this to grant. I'm not necessarily going to stay this way, but just for the sake of our conversation, grant. User.get trust get. So rather than starting with the keys first, you do the path, and then you put their pub key. Okay. So now, do you see how it's inverted? With Grant, we do the table, the metadata table, then their public key, then the path. With trust, we do it the opposite way around, because what we want is any random Joe who's going to read this data is going to, so now let's say there is some random Joe viewing the data.
So Grant is giving them read access to encrypted data or not encrypted data, and Trust is making them a participant, which creates then that shared view that we were talking about earlier with the mix-in. Is that correct?
Yes, but you're gonna, so you have to do the mix that you explained earlier, which I'm not going to go over. But in order to figure out which things you mix, you have to do this similar. So random Joe, who's not Alice and not Bob, Joe. So Joe is going to do a gun.user, and imagine me as Bob, and then I need to go. So Joe does a read on gun.user Bob, okay, .get blog post .map, no, I won't do that, get 2019 dot this is where we do need the read API, but I'm just gonna let's call it trusted read. That's not what I don't want it to actually be called that, but because that's hideous, it goes against my standard. But you can think, so trusted read data, console.log data. And so the goal is that from this trusted read extension is going to return to you the mixed data. But in order to mix the data, it has to do a lookup on who's allowed to be the mixed data. And that's then where, back over here in trust, it's going to do something very similar to Grant, but with things reversed. Okay, so that way the trusted read, trusted read knows, do a lookup on this gun chain directly, and that gets Bob's copy of the data. Do a lookup on the metadata trust table for this path. That gets all the pub keys allowed to write on this path. Do a lookup on each of those pub key user graphs, pub keys on the path to get the collab data layers. Okay, I'm going to use the analogy because it's much easier to think about this in Photoshop than the cryptography. So now you have the original authors layer. You've looked up the author's list of who the other layers should be, and now you look up, and now you get each of the layers. Then you perform Yachin's mix operation and return the result of that to right here. So now end developers who are not helping build C and the library C are just instructed to use this API and to use trust and to use the trusted read API, which is going to be a different, it's probably going to be named the same. And then what they will get as the end developer building an application is all the data merged for them in this returned data set that they then pass to React to display. So does that make sense? As far as code, so you combine what Yachin explained earlier with this table structure, and you then combine all the things, and that gives you all the pieces you need to know. It gives you the source of the data, it gives you the ACL on that data, and then it gives you the layers for each of the permitted ACLs, and then you do the merge operation that was already that Yachin gave the code for, and then you return the result. And now, ideally, everybody in the community is just using this API, and they don't have to know about all this cryptography and layer stuff underneath. Like, that's all complexity that we can hide from them. Does that make sense?
Makes complete sense to me.
All right, and now I have to go, but I want to drop one last bombshell. Where this metadata exists is also another complex question. Should it be saved? Should it be saved in line? Should it be saved in line on the data itself? Should it be saved in a table, or should it be saved in some other weird data structure? So now, where is metadata saved?
And this is where I said we need to standardize, because you want that to be the same everywhere, right?
Exactly. In order for this API to be useful, we basically have to make sure we standardize across all of these questions. So that way there's one, that way all data is being, with this API, is being saved with the same format and the same structure that any other reading API is able to pull.
So maybe this is going to turn into a huge rabbit hole, but this decision, isn't it inherently very much linked to the decision to standardize around JSON? And have we considered whether or not some other data format would help with this whole question?
Oh gosh, that is a whole nother layer. But the good news is that can be safely isolated, and was already safely isolated at the layers of gun and C itself. So we don't need to worry about that question. That is a whole question, but that was standardized about a year and a half ago, I think, when we had a disaster with that. I made mistakes with not a bug that I then fixed, and we've modified and revised. Yachin was around for the time and could probably. I need to run now, but we should probably do a separate. We can do a separate call on that. But that is a layer that's already hidden, and we don't need to worry about anymore. But yes, it's impacted.
All right. Let's do this again.
Wait, so if we can organize another time to meet, I am more than happy to, like, myself implement any one of these options. And you saw I already started with trust and graph. The most important thing, though, is that I kind of want consensus with the community and kind of a mathematical view of what's going to be the most powerful layers to start with. And then ideally, hopefully, there's going to be multiple people in the community that can, like, implement this and or maintain it. So that way I'm not stuck with fixing all the bugs when I have Gun and Rad that I'm working with.
Why don't we put them into some branches? You know, then you could allow them to compete, see which one actually people like when they interact with it. And I had another idea of putting together a page where you could have a split view with two iframes, so that you can have Alice and Bob in one session as the person trying to evaluate the app and evaluate Gun. I was thinking of maybe that would be a cool way to set up a lot of these examples that we're talking about.
Yes, we want to be careful we don't create fragmentation, though, that then leads to bad developer experience.
Well, I think that the multiple branches is just a momentary situation where you basically say we've got these two and eventually one is going to win.
Yes, and that should be very much be a community and scientific, not like academic, but like like community and science driven decision. It's not for us people who are wanting to maintain work at the library level. I don't think that's a decision that should be handed over to the app developers, or else. Okay.
No, I wasn't.
Perfect.
No, I wasn't.
Yes. So let's resume that conversation. LightNet. If you want, hopefully from Yachin's explanation, plus then me going over the code here, you could basically copy Grant into Trust, swap things around with your own API that then does the ACLs if you want to just get something working, and then publish it with the mix code. And then I'd be more than happy to evolve on top of that, and then we can see, and then we can potentially try one of the other branches, and then that will help us make progress. So is it LightNet for you specifically? Is this like enough to at least give you some food for thought or to do some coding? Yeah. Okay, cool. And more than happy to do more of these. Probably more daytime though. Okay, I'm gonna run, but I'm not trying to cut the conversation short. Just I want to do more of this, but got to get back to the kid. Have a good one. Thanks all.
So yeah, thanks
Bye.
for your time.